So the estimate of the coefficient of kinetic friction is 0.10. First, draw the free body diagram and calculate her acceleration and the speed she will reach after 4 seconds.
Okay, so you have a skier who's starting to ski down the slope, right? And the slope has an angle of what? 30 degrees, okay? So therefore, let's look at letter A again. And I'm just going to repeat what I just drew here. So draw a free body diagram. So if this is your slope, you have your dude here. Okay? And she is, no, she's a dudette because it's a she. So what are the forces acting on the skier now? The usual? Force of weight, okay? So force of weight is going down. And what is force of weight equal again? M times G. What else?
Normal force.
Normal force. What's the direction of normal force, Mr. Andrade, if you can remember?
Straight.
Straight.
No. Kelly say it.
Perpendicular to what?
To the ground.
It goes upward.
To the surface, okay? To the slope. So it's going to go this way, right? Okay, now since she is skiing down, in which direction is friction going? To the left or to the right?
To the right.
To the right. So force of friction is going, oops, in that direction, right?
Yep.
Okay. And again, our Cartesian coordinate system will look something like this. This is positive x. This is going to be positive y. So anything going down would be negative y. Anything going to the left would be negative x, right? Okay. So the only thing that they give us is the angle here, which is 30 degrees. So we have, so that's letter A. Now so that's all the forces that you need. Now, do you need to draw the x and y components? Yes or no?
Yes.
Unless specified by the problem, do not draw the x and y components. Okay? Unless they are specific about it. Because during the AP test, if you draw the x and y components, they'll take it against you. They'll take off points. It's like they say -1 for every extra force. Now, in order to solve, however, we need to find the x and y components, right? So therefore, in order to find the x and y components, you could do it in a separate drawing. But in this case, let's just do it over here since you already copied down the forces. So what's the first thing that we need to do? What is the first thing that we need to find out? The x or the y? What do you think? X or y component of the force?
Probably the y.
I'm sorry, the
Y.
The y component, okay? Now to draw the y component, let's draw an arrow, broken arrow from the tip. And then, this is now our FW, x or y again? Y, okay? And what is it equal to again? Sine or cosine? So it's equal to cosine times the hypotenuse, which is FW, right? But what is FW equal to? Again?
mg.
Okay, so FWY is cosine theta mg. Okay, if you notice, we're repeating and repeating. Now, what's the next thing that we're looking for? Well, since we're going to find its acceleration going down, might as well find the y component.
X.
Or x component. Thank you very much, Mr. Januszewski. And this side is equal to this side, so it's FW x. And how do we find this side? Sine or cosine?
Sine.
Okay, so this is sine theta, and the hypotenuse is FW. But what is FW equal to? I'm sorry? Mg. So we will now write sine theta mg. Okay, so far, are you good? Yeah, it's just, we're just putting in numbers here. Okay, now we have to find the frictional force. But before we find the frictional force, we should find the, what? The normal force. Okay, normal force is equal to FWY.
Y.
But we know that FWY is equal to what? It's equal to cosine theta mg. So, it's just a matter of substituting this with that and that, but they're just all related. Okay, so far, are you okay? Okay, can we now look for the frictional force?
Yes.
Okay, what's the formula for frictional force?
Mu sub
UK
n. Or mu
F sub n, right?
That's it.
But what is F sub n equal to?
FWY.
FWY, which is FWY is also equal to cosine theta mg. So therefore, we do this, it's going to be mu sub k cosine theta mg. Now we have everything, we have already all the forces that we need, and we've broken them down already, right? Okay, but have we solved for the acceleration? No. Okay, so now let's solve for the acceleration, letter B. And where do we start it off? What's our original, which equation do we start off with? OMG. What's the starting formula to find the acceleration? Huh? I'm sorry, Oswin. I'm sorry?
Net force divided by
Net force? No, it would just be sum of all the forces is equal to mass times acceleration, right?
oh yeah, but acceleration.
Oh, acceleration is force divided by the mass. You're right. Okay. Now, what are the forces that's causing the skier to slide down or glide down the hill? Which force is responsible for causing the skier to go down the hill?
Gravity.
Gravity, this one here?
Yeah, the weight.
Or one of its components? Which component is responsible for making the skier slide down the slope?
The X component.
The X component, right? Okay. So therefore, it would be the FW X, right? Isn't it? Now, what is its direction? Is it going to the left or is it going to the right? This FWX. Huh? It's pulling the skier down here to the left, right? And by origin, we already stated earlier, but I just erased it because I needed more space, plus X plus Y. If something is pulling to the left, is it a positive or a negative?
Negative.
Negative, okay. Now, is there any force that's pulling the skier to the right or preventing it from going down the hill?
Friction.
Okay, you see that arrow over there? So friction. So it's going to be F, force of friction, right? Isn't it? Now, you might think, I thought friction is slowing you down, so it should be something negative. The arrows that we are using here are just for directional purposes. Anything that's negative is going to the left, anything that's going to the right is positive. But it's just for directional purposes. Equals the mass of the skier. Now my question is, in which direction is the skier accelerating? Going downhill, right? And anything going downhill, is it going to the left, is it positive or negative again?
Negative.
Negative. So what am I going to write here? Times a negative A. Alright? Still good?
Yep.
My. Alright, what is FWX equal to? Where is FWX equal to?
Cosine, no,
F
sine
W X?
theta.
Sine, right?
Yeah.
Yeah. Okay, so
I'm in
negative
the top one.
to show that it's going to the left is sine theta mg. What is friction equal to?
Cosine theta mg.
Mu sub k.
Jeez, why am I doing this?
Mu sub k cosine theta mg equals negative m a. Right? So far, you're with me? You're good? Yes, Mr.
Can you
Hughes.
watch the
Okay.
video anytime?
You just replay it on video later, okay?
I'm so excited.
All right. I know you'll start making fun of me, Mr. Hughes.
No.
It's okay. Now, what are we looking for, by the way? I forgot. What's our focus here? We're looking for the acceleration. Okay. We want to isolate A. Is there any factor in both sides of the equation that that we can cancel out? There's a common factor for all the terms.
Yeah.
Mg? No, but there's no G here.
You can divide it by
So it's just M. So what can we do so we can get
divide it by
divide by M?
negative m.
Okay.
Negative m.
Yeah, whatever you do to one side, if you could do it to
Is
the
it
other
negative
side,
M?
then it's fine.
Oh, yeah, you can't do that.
So it doesn't matter what is the mass. So any skier, if they will just slide down the hill, one fat one and one skinny one, if they have the same conditions, like their skis are the same, then they should go down at the same rate. Mr. Andrade, you were raising hand.
Is it negative m or no?
I'm sorry?
Is it negative m or no?
Yes.
Oh, it doesn't have to. Just
Only
M.
negative because it's negative acceleration. So you multiply.
Okay, so what's going to happen now is all the m's will cancel out, right? So you will have negative sine theta g plus mu sub k cosine g equals negative a.
Forgot your theta.
Did I forget the,
G.
oh, cosine theta, yeah, right. O and J. Okay, so far you're good? Okay, and you can make it even simpler. What's a common factor here? G. So it's going to be negative sine theta plus mu k cosine theta. Or you could have it the other way around, like mu k cosine theta minus sine theta. They're just the same thing, right? Okay, now let's plug in our numbers. 9.8. Negative, how much is sine 30? Sine 30, if I'm not mistaken, is 0.5. Yeah, sine 30 is 0.5. And then times 0.10 times cosine 30, if I'm not mistaken, is 0.867 equals negative 8. Alright? So it's going to be 9.8 times negative 0.5 plus 0.0867. Okay, and according to my notes, I'm supposed to get like 9.8 times, how much is 0.5 minus 0.0867?
I got negative 0.4123.
After everything? After
Oh,
subtracting?
after everything, I got negative 4.0.
Yeah, that's what I also got. So negative A is equal to negative oh no,
4.05.
4.05. Okay, and since they're both negative, so practically acceleration is equal to 4.05 meters per second squared. Yeah? You're good? Yes?
Yes.
Okay, now the last part is actually very, very simple. You don't even have to worry about it because it's like, I'm sorry? No, we've actually solved B.
Okay, so now it's just.
And then it says C said what will be the speed after 4 seconds. So basically to do C, it will just be final velocity is equal to initial plus the product of acceleration and time. What's the initial velocity? What's the initial velocity?
0, wouldn't it be?
0, because the problem said she began to descend. So
Yeah.
0 plus 4.05 times 4 seconds. And if I'm not mistaken, I got 16.2 meters per second. Very easy, right? Yeah? Okay, cool. Mr. Becker, can you please read the last problem? Measuring mu sub k, or the coefficient of kinetic friction.
Suppose in example 4-17, the snow is slushy and the skier moves down the 30-degree slope at a constant speed. What can you say about the coefficient of friction u sub k?
Okay. Now it's basing itself on this problem again, but there's one important detail that the problem is telling us. And what is that important detail that I want you to take note of? Constant speed, right? And Mr. Murillo, if the speed is constant, what can you say about acceleration?
It's 0.
It's not accelerating, right? So acceleration is 0. So I wrote here, if delta v, if the change of velocity is 0, then acceleration is 0. So this time, the skier is not accelerating, it's just moving at constant speed. So there's a bigger friction now. Now, would there still be the Fwx that's causing the skier to go down the slope? It's still present. Is friction still present?
Yeah.
Yes. In fact, it's even greater than the previous problem. Okay? Now, so these two forces would still be the same. So therefore, practically, it would just be this one here. Isn't it? This is what we started off with in the previous problem. We said the force, the x component of the force of weight is pulling the skier down, while force of friction is slowing her or preventing her from sliding down the slope. That's why we have this equation, right? And then we kept on substituting. What is the only difference in this formula now here?
Acceleration equals 0.
Acceleration is equal to
0.
0. So instead of a negative a, what will happen now here? It's equal to 0, right? So what will happen to this one on the other side? Even if the mass of the skier is 1,000 kilograms, which is impossible, 1,000 times 0 would be
0.
0, right? Isn't it? So therefore, what's going to happen now? If I wrote it down like this, if that's equal to 0, so it will now become Fw sub x plus force of friction equals 0, right? So what is the force of friction equal to?
The force of x.
Isn't it? You move it to the other side? Isn't it?
Yeah.
So force of friction now is equal to Fw sub x. Yes? Yeah? Okay, how do you find the force of friction again? What is force of friction again? Okay, mu sub k cosine theta mg, right? And Fwx is, what is Fw sub x? Sine theta mg. Now remember, we're solving for mu sub k. How do we isolate mu sub k in this case? If I want to isolate mu sub k, divide by cosine theta mg, and I'll divide this by cosine theta mg. This one cancels out. What cancels out on the other side? Mg, right? Not theta. So mu sub k now is equal to sine theta over cosine theta. And if you are like Josue, who studied pre-cal last year, Do you remember what is sine theta divided by cosine theta? Actually equal to tangent theta. You can simplify it. But let's just say we did not study pre-cal yet. So, how will we find the value of mu sub k? So, sine 30 degrees divided by cosine 30 degrees. And if you get your calculator, sine 30 is 0.5, cosine 30 is 0.87. Just use your calculator. So therefore, mu sub k now is equal, if you divide that, you're going to get an answer of 0.58. Yes or yes?